Good afternoon, grade 9. Welcome to this first lesson of the third term. It's electrical and electronic systems. I know you have done that in the previous grades. You have done electrical and electronic systems. But in grade 9, we add electronics. In the circuit diagrams we'll be doing today, you'll be getting a revision of the component symbols that we will be using. You will just identify them in the circuit diagrams that we will be doing. We'll do series and parallel connections, simple circuits, and we'll do Ohm's law. It's a revision of what you have learned so far in electrical systems and control. Today, mainly we'll focus on electricity, on the electrical part of it. We'll not go much into the electronics. Okay. So, you remember your simple circuits that you started connecting from intermediate phase in natural sciences and technology. Okay. Let us look at this. Try and remember the symbols that you use for this. You will see these circuits in graphic representation as we go on. But what you have there is a power source, and you have your crocodile clippers and your wire and a lamp. That's a simple circuit. Now, the load here is the output component. In a circuit, we also have an output component. I know that when you did your hydraulic systems, hydraulic and pneumatic systems, we were talking about the input and the output, the input cylinder and the output cylinder. We still have the input in the output here. All right, the input is the power source. The output is the output component. It can be a lamp, it can be a buzzer, it can be any other component which we want the current to end, where we want the current to end, or where we are directing the current in the circuit. Okay, so I want you to understand the concept of resistance, because we are going to do a lot of resistance this term. Resistance in this regard is on the lamp, okay? In this circuit, the output provides resistance. So resistance is provided by the lamp in this regard. If the output here was a buzzer, the resistance would be provided by the buzzer. Okay, so in a simple circuit, we say resistance is given by the output component. So we have your conductor, it transmits, okay, transmits current. Okay. Now you have 3 cells connected in series, a series connection. Okay, you see there's a lead. Okay, we'll call these conductors, we'll call them leads as well. There's a lead between the first power source and the second one, and that makes a series connection. Okay, that makes a series connection. Let me hear what you have to say. So this is a series connection of the power source. May I ask, What do you understand by a cell? What is a cell in electrical systems and control? I know in natural science, in life sciences, in natural science, you call a cell something, okay, that is the basic part of the body or a plant. But in this regard, what is a cell? How to know that this is a cell? What kind of a power source is it that we call a cell? Grade 9s. Hello? You don't have to talk to me. Think it's a cell. What is the difference between a cell and a battery? Okay. I'm sorry, you lost me there. I think I lost connection. Okay. Any power source. This is a power source. Grade 9. This is a power source. Any power source that has a voltage to the value above 1.5 volts, now that's a battery. Okay? If it's connected in series, that's a battery. Any series connection. So this is our battery now. This is our battery. Okay? If it's one cell, it's a cell. If it's 1.5 volts. But you do find a battery in 1 unit. Okay? A battery. As long as the value of the voltage is above 1.5, that is a battery. Like the 9V battery, you find it in 1 unit. It's not a cell, it's a battery, because inside it has many connections of 1.5 volts cells. Okay, so this is a 3 cells connected in series. I hope you can remember now the series connections. Cells in parallel. Okay, now these cells are connected in parallel. When cells are connected in parallel, the total voltage of the cells is the same as that of a single cell, 1.5 volts, when they are connected in parallel. Now, this will remind you of symbols that we use, the graphic symbols for our electrical components. Let me bring you. This is, where's my cursor? Okay. This is a battery. How many cells are in this battery? How many cells are in this battery? Three cells. 3 cells. Okay? Now, when you draw your circuit and it has one cell. It will have this unit. This unit is one cell. So here we see 3 cells. Now this is a graphic symbol for your conductor. And you draw your lamp like this. This is your graphic symbol for your lamp. And you have in this circuit, you have your lamp 1. Lamp 1 connected in series with lamp 2. Okay? Now, connection of lamps. 2 or more lamps can also be connected in series. In the previous slides, you saw cells connected in series and cells connected in parallel. The pictures below show circuit diagrams of 2 and 3 lamps connected in series with the battery. The positive terminal of the battery, the positive, the plus B, is connected to lamp 1. Okay, so it's this part. The positive, this is the positive, it's connected to lamp 1. And the other side of lamp 1 is connected to lamp 2. Okay, what are we using to connect? We use the conductor. Okay, the other side of the lamp is connected to lamp 2. The other side of lamp 2 is connected to the negative terminal of the battery. So, just a reminder, this is your positive and this is your negative. This is your positive, this is your negative. So this is a series connection. And here you have a series connection of 3 lamps. Okay, from the electricity that you have done, the circuits that you have done in previous grades, let's talk about this. What do you predict here? How is the light intensity of this circuit compared to the light intensity of this one? What happens with the output of a series connection of lamps? What happens? Can you remember? What happens when you connect lamps in series in a circuit? Grade 9. Okay. So the light intensity, you know, when you connect, okay, I'm getting an answer. It becomes dimmer. We do mellow, very good. It becomes dimmer. Okay. This circuit, the output, the light is dimmer. And here, the light is even dimmer. Because as you go on and on connecting output components in series, then you get a reduction of the output. Okay? Right. Connection of lamps in series. Let us look at how that affects the current and the voltage. The overall voltage drops across the lamps. The voltage drop, it remains the same, but the current decreases. So from this, The voltage here is 4.5 volts. In this circuit, the voltage is still the same, but the current decreases. How do we see that the current decreases? We see it on the input. Okay, the lights, they are sharing the current, so the current decreases. Okay, if all the lamps have the same resistance, the voltage drop across each lamp will be 1.5 volts. When the voltage drops of all the lamps are added, the total battery voltage is 4.5 volts. Okay, the current is the same throughout each lamp. If the value of these lamps is the same. You know that lamps have different values. So if these lamps have the same value, the same capacity, so they will equally share on the 4.5 volts. 4.5 volts is three cells. So they will be each sharing 1.5 volts because they are equal. Okay? So the current would be the same. So even their light intensity, when you look at them, it would be the same because they would be sharing the current. Okay. It would be different if their values were, if there were lamps of different sizes. Parallel connections. Let us look at lamps in parallel. We did look at the power source in parallel, but now let us look at lamps in parallel. The applied voltage is the same across each lamp. They don't share the current. The applied voltage is the same across each lamp. The current is divided across each lamp, and the total current is the sum of the current through each lamp. Okay? This is the way in which they will be sharing the current. Okay? So LT is L total, is lamp total. Lamp total equals lamp 1 plus lamp 2 plus lamp 3. This is why in your house, you don't have a series connection of your lamps, of your lights. You don't have a series connection of your lights in your house. If the person who was doing the electricity in your house knows electricity, they won't connect lamps in series. That is why when you turn on the switch in any room, the light intensity is big enough for the capacity of that lamp, of that light. It doesn't go dim. I know that in our houses, we have that switch where you can dim your lights. But the lights get all the current. So each and every light will be having its maximum output from the battery source, from the power source. Okay, it will not be like in the series connection. Okay, so that is the advantage of lamps in parallel. You can add whatever number of lamps as output components in this circuit, but the light intensity will be the same. It will be the maximum. Okay. Right, understanding parallel connections. Look at the certain circuit diagram below and answer the following questions. What is the voltage drop across lamps 1 and 2. What is the voltage drop here across lamp 1 and 2? LT equals what? What is the voltage drop across each lamp is 4.5 volts, which it will actually be slightly less than that because of the internal resistance of the battery. Remember, okay, we will go to Ohm's law, where you will see the relationship between current, voltage, and resistance. Okay, don't worry a lot about resistance for now. We just know that output components, they offer resistance in a circuit. But let us look at the voltage drop in these lamps. Each one of these 2 lamps will be getting 4.5 volts from the battery. So you will be getting an output to the value of 4.5 volts in this lamp 1, and the same here, because they are not sharing like the ones in the series connection. Okay. The total current in a circuit is 10 amps. What are amps? Who can tell me what are amps? Amperes. What are amperes? What do we use them for? Grade 9. Grade 9. What are amps? Amps are units that we use to measure current. We know that you have seen these volts, okay? Volts are the units that we use to measure voltage. Where do we get voltage? From our power source, okay? Current. Current is what is transmitted from the power source to the output components through the wires or the conductors. So current is measured in amperes. We call them amps. Okay. In your multimeter, you will find your multimeter you will find features to measure voltage and to measure current and also to measure resistance. Okay, that's the beauty of the multimeter. So another reminder, what you need to have when you are studying electricity and electronics is a multimeter. It is your stethoscope, like the stethoscope of the doctor. The doctor always carries his or her stethoscope. So you'll be carrying your multimeter if you specialize in electricity or electronics, right? If lamp 1 has a current of 4 amps flowing through it, what will the current be through lamp 2? It's a total of 10 amps minus 4 amps that goes to lamp 1. So lamp 2 will be getting a total of 6 amps. Obviously, perhaps the capacity of these lamps is not the same. Let's look at further parallel connections. We are looking at circuit connections. We can have a connection of switches in parallel. This is the symbol for switches. I want you to note these graphic symbols as we go. We have different kinds of switches, different kinds of switches. But when you draw your circuit diagram, you use this symbol for switches. When you look at this first symbol, the switch is open. Okay? When we say the switch is open, we don't mean that the current is flowing freely. We mean the switch is open, so it has cut the flow of current. Here, the switch is closed. Because the switch is closed, current is flowing. So there's a flow of current in the closed switch. So when you turn on your switch, turning on your lights, you are closing your switch. When you turn off the lights, you are opening your switch. I want you to understand this close and open language. We can use 2 or more switches to control components in a circuit or in more complex ways. In a logic circuit, an open switch is regarded as having a value of 0, and a closed switch as having a value of 1. Some switches that they manufacture today, they do have this. They show you that when the switch is off, there's a 0 there. And when it's on, it has a 1. But most switches don't have that. Even the switches I'm looking at now, they don't have that. Some have a red line to show you whether the switch is on or off. The switches are inputs that control the final stage of the circuit, okay? I can say switches are circuit breakers, okay? I can say switches are circuit breakers because they break the flow of the current in a circuit, okay? And they are control components. Switches are control components. Switches are inputs that control the final stage of the circuit. If the circuit is not completed, the output is in the off state and the value is 0. The value is 0. The switch, when it's off, it's 0. When it's on, the value is 1. So you have to understand that before we go to the truth tables. Now let us look at a series connection of switches. You have your battery there, okay? And you have your switch there. And there's your output component. The output component in this switch is a lamp. We know that output components can be other components, not only lamp, but we like using the lamp. Right, let us look at this circuit. Switch A and B are both open. Okay. What happens when switch A and B are both open? Will the output component, will the light be on here when these 2 are open? Will the light be on? Grade 9. Will the light be on when these 2 switches are open? No. So what is the value? Do we attach the value of 1 or 0? The output is 0. Okay. Switch A is open and switch B is closed. This one is open, but this one is closed. What is the output, 1 or 0? This one is closed. but B is open. What is the output? Do we get a 1 or a 0 here? We get a 0 because there's no flow of current. Very good. Grade 9. So switch A is closed and B is open. Do we get a 1 or a 0? We still get a 0. Okay. When both switches are closed, what do we get on the output? We get a 1. Very good. Okay. Now, let's see. We can put that in the truth table. We can put the behavior of this output component, which is a lamp. We gave it values when these switches are closed or open. Now we can put this in a truth table. We call this a truth table. When we connect circuits, we look at the behavior of our circuits, then we analyze it in a truth table. In the below table, 0 means off or open. Remember, when the switch is off, when you say the switch is open, it means it's off. And 1 means on or closed. Complete the table to show all the different combinations possible in the circuit. In figure 11, this is figure 11, you'll be doing this. I took this from your workbook, the Sasol Inzalo workbook. Okay, you will find it in your learner's book. To help you, the first 2 rows of the table have been already completed. Make sure you understand those 2 rows before you complete the rest of the table. We did it that side, but let us look at this, okay? So if this is 0, it's open. Switch 1, input A, it's open, and switch 2, and switch B, switch A is open, and switch B is open. The output, the lamp, is 0. So 0, 0, 0. And if input A is open and input B is closed, the output is 0. You did that in that other slide. And here, if input A is closed, input B is open, the output gives us 0. You said so, ne? So this will be our truth table. If the input A, the first switch, is closed, input B is also closed, the output will be 1. So what do we deduce from that? What can you conclude from that, looking at this circuit? What does it take for this circuit to give us an output? What is this truth table telling us about this circuit? You can write the conclusion in 1 sentence. Grade 9, what can you conclude about this circuit with 2 switches in parallel? Okay, this is the conclusion. For us to get an output, we need to close input A and input B. For the current to flow to the output, we need to close both these 2 switches. How do you know that? We saw it when we were doing our truth table. Right, now let us look at switches in parallel. We have seen switches in series. Now let us look at switches in parallel. This is the parallel connection of switches. Believe me, I could just can switch. There's our output, the lamp. Okay, let's look at the truth table for this circuit. This is the truth table. Let us understand this truth table. It's not like the one for series connection, right? This truth table is teaching us something about parallel connections of switches. Input A is open, and so is B. There is no output. But if input A is open and input B is closed, we do have an output in the lamp. Remember, in the series connection, when one switch was open, we didn't have the output on the lamp. But series connection is different. Okay? I will explain to you why. Input A is closed. Input B is open. We still have an output on the lamp. The lamp will shine. Okay? And when both the switches are closed, the lamp will shine. Why is that? Now, there is this saying that current will follow the easiest route in the circuit. Okay? The current will flow in this direction because it is not obstructed and come to the output. Okay? If this switch is open and it interrupts the flow of current, the current will follow a route that will allow it to flow. So that is the beauty of parallel connection of switches. It means the lamp will shine if one of the switches is closed. So this is the truth table. So now we know that in parallel connection of switches, we only need one switch to be on, and then we'll have an output. Okay. In this case, the output is the lamp. It can be a buzzer. The truth table shows that when switch A and B is, when switch A or switch B is closed, the output will be 1. The lamp will be on. We call switches in parallel an O function. Okay. We have an AND and an O function. So for me to turn on this light, I need an input in any of this, it can be this one or that one, I will have an output. Whereas this one, it's an AND function. The parallel connection, it's an AND function. Because for me to get an output, I need this one switch and this one switch to be on, and then I will have an output. So this is an AND function, A-N-D, AND function. Whereas this one is an OR function. Why? Because for me to have an output, I need to have this one switch on or the other switch. So it's an OR function. Right. Now let us look. Would the lamp glow in each of these circuits? Let me see how much time we have. Okay. Let us do just this one. Looking at this circuit diagram, do you think the light will glow? We have just done that. Do you think the light will glow? Yes, because the lamp is part of a complete circuit that includes the battery. There is a continuous conducting loop, including the lamp and the battery. Okay, you can just skip in this circuit, you can skip this switch. The current can skip it. It will just go where the route allows it, then come to the lamp. So it's a continuous loop of current. Okay. Now, grade 9, let me end the lesson here. We'll continue with circuit connections, trying to predict if we'll get an input to ensure that you understand the flow of current in different connections, parallel and series connections. Have a lovely afternoon. Thank you. Bye.